Hello, grade 12. Welcome back to the channel, Science Therapy. In today's lesson, we're going to be looking at sequence and series. And then we are looking at these activities here. So without any further ado, let's just get right down to it. Okay, so we are given the sequence 3, 5, 7 is given. And then A says determine the general term. So we already know the formula to determine the general term is Tn is equals to A plus n minus 1 and then D, right? So the A represents the first term, right? And then the D will represent the difference, right? So how do we find the difference, the common difference? We just say D is equals to T2 minus T1, right? So what's our T2? It's 5 minus 3, that's equals to 2. And then also again, we can say T3 minus T2, that's 7 minus 5, also equals to 2. So the A is equals to 3, and then n minus 1, then D is equals to 2, right? So that means we have 3 plus 2n minus 2. This gives us 2n plus 1. So that's our Tn. Just like that, you have found your general term, right? Then we are done with A. Now for B, they say which term is equal to 71. Remember, this one, you need to use this general term that you've just calculated to find which term will be equal to 71. How are we going to approach this one? All you have to say is T n is equals to 2n plus 1. Then which term you are looking for n. So you put 71 here and then 2n plus 1. Take this one, transpose it over here. So this will give us 70 and then 2n. Divide both sides by 2. Our n will be equals to 70 divided by 2. That's equals to 35, right? So that means the 35th term will be equal to 71, right? Now, when we go to C, it says which term will be greater than 41. So this means we are still using the same general term, but this time around we'll be using an inequality sign. So that's 2n plus 1 greater than 41, right? So 2n, if we transpose that 1 over, that's 40. Divide both sides by 2. My n is greater than 20. So what does this mean? It means if I substitute 20, I will either get a value that is equal to 41 or less than 41. But then if I substitute a number that is greater than 20, let's say an integer, the first integer would be equal to 21, right? So this will give me a value that is greater than 41. Okay, let's try it out. Let's say first, let's substitute 20 into this equation. I want to have 2 times 20 plus 1. If we say 2 times 20, that's 40, plus 1 is equals to 41. So 41 is not greater than 40. 41 is just equal to 41, not greater. Then that means for term number 20, we have a value that is equal to 41. But the question is asking us for the term that will give us a value that is greater than 41. If we substitute 21, say 2 times 21 plus 1, 2 times 21 gives us a 42, then plus 1 is 43, right? So now 43 is greater than 41. So that means term number 21, therefore the first term or the first integer that will produce a value that is greater than 41 is 21, right? So this is the first integer that will produce a value that is greater than 41 in this sequence. I hope this makes sense. Now, D says determine the sum, keyword sum of the first n terms. Now, if they say determine the sum, the formula that we use for the sum of n terms of an arithmetic sequence. So this formula is only used for an arithmetic sequence. Is Sn is equals to n over 2, then big bracket 2a plus n minus 1, and then d, then close bracket. So this is the formula that you use. It appears in the back of your formula sheet, so you do not actually need to memorize it, but only to know how to use it. Right. So now they're saying determine the sum of the first n terms, right? This is not like that. You saw how we dealt with the general term. Now we are dealing with the sum. So if they want the sum of the n terms, this is the formula that we have to use. So it's n over 2, then 2, our a, that's still our first term. We're going to substitute 3. And they just told us n terms, so we're just going to leave it at n there. Then our d, we already concluded that it's 2. So we substitute 2 here. Then we just have to calculate here. 2 times 3, that's 6. 2 times n, that's 2n. 2 times negative 1, that's minus 2. Right. So we have n over 2, and then bracket 2n plus 4. Right. Now at this point, if we multiply this, remember we have 1 over 2. As you have it like this, this is the same. N over 2 is the same as having 1 over 2n, right? So 1 over 2n times 2n, that will give us n squared, because the 2 and the 2 will cancel out. Then 1 over 2 times 4, so half of 4 is 2, so that's 2n. So that means our Sn formula is n squared plus 2n, right? We are done. That's it for calculating D. Now E says, hence calculate the sum of the first 40 terms. Hence calculate the sum of the first 40 terms. Remember, our Sn is equal to n squared plus 2n. Then to calculate the sum of the first 40 terms, that's 40. Where there is n, I substitute 40. Then just like that, I will have my sum. So the sum of the first 40 terms is 1,608. Then let's proceed. Exercise 3. How many terms of the series 3, 8, 13 must be added to give a sum of 2,265, right? So keyword sum. Once they mention sum, and then we know that this is an arithmetic sequence, what we have to do is just write the formula Sn is equals to n over 2, and then 2a plus n minus 1, and then d, right? So now let's find the difference between these terms. If we say 8 minus 3, that's 5. 13 minus 8, that's also 5, right? So now they say, how many terms? What are we looking for? How many terms? We are looking for n, right? Must be added so that the sum, the sum is 2,265. So 2,265, we are looking for this n here. So we're not going to substitute anything there. Our a is 3. So 2 times 3 plus n minus 1. Then the d is the common difference. So we have 5. And then let's just solve here. 2,265 is equal to n over 2. This will give us 6 plus 5n minus 5, right? So this is 2,265 is equals to n over 2, 5n plus 1. So 6 minus 5 is 1. Then 2,265 is equals to 5 over 2 n squared. Then this multiplied by that plus half n, right? Then this is 5 over 2 n squared plus half n minus 2,265 is equals to 0. Now, all we need to do here is multiply both sides by 2 in order to get rid of this fraction here. So 2 multiplied by this 2 here, we end up with 5n squared. Then if we multiply this 2 with this there, we end up with n. And then this 2 multiplied by the 2,265, it's giving me 4,530. then equal to 0, because 0 multiplied by 2 is just 0, right? Now, because these are very big numbers, you can just go ahead and apply your quadratic formula in order to find your values, right? So it is allowed because this is in quadratic form. So we just simply use your quadratic formula, guys. Then the values that I get from this one are n is equals to 30. So I'm just going to write n minus 30 because I just want to write it as if I factorized. Then this is 5n. I got negative 151 minus, so let me punch it in my calculator again. Then 1 squared minus plus square root 1, yeah, that and that and that. Okay, so I'm getting a 151, negative 151 over 5. So I'm just going to write it as 5n plus 151, right, is equals to 0. So my values are n is equals to 30, or n is equals to negative 151 over 5. So if you were to punch it in your quadratic, then that means you'd have the answers like this, and you wouldn't have this factorized method here. Okay, so this is n is equals to 30, n is equals to negative 151 over 5. But then remember, with the conditions for n must always be an element of natural numbers, right? So that means this is not a natural number here. A natural number is not negative, cannot be negative, and it cannot be a decimal as well, right? So if you punch this one, it will obviously give you a decimal, right? So n must be an element of natural numbers. That means the correct answer is 30. So how many terms must be added in order for you to have a sum of 2,265? You must add 30 terms. You must add 30 terms. Okay, then let's proceed to another one. Okay, so let's look at activity number 4. It says the following arithmetic sequence is given. We have 20, 23, 26, 29, and then we skip a whole lot of values. Then we have 101. So right now, in order to prove that this is an arithmetic sequence, we know that we have to find whether it has a common difference. So looking at the numbers that we are given here, we can just simply say T2 minus T1. This is 23 minus 20. It's going to give us 3. 26 minus 23 also gives us 3. 29 minus 26, this is also 3. So because we have that consistent difference, then we know that this is an arithmetic sequence, right? Now the question here says, how many terms are there in this sequence? This question is quite easy because now we can see that we are given the value of the last term. Remember, we said with these questions, if we are given the last term, we can simply just calculate the position of the last term using the general formula or the n term. And we know that if we find the position of the last term, this will in a way represent how many terms are there in the sequence. So we're just going to go ahead and say Tn is equals to a plus n minus 1d. So we are using the nth term formula. Then for Tn, we substitute our 101. What is our a? That's the first value. So we have 20 plus n minus 1. But what is d? Our d is 3, right? So at this point, we need to say 101 minus 20. So we can take this 20 over to this side. So this would be 101 minus 20. That's 81. Then if we say 3 times n, that's 3n. We say 3 times negative 1, that's minus 3. Now at this point, we can take this minus 3 over to this side. So that's 81 plus 3. Remember, when it jumps over to this side, it must change the sign. So this is 84 is equals to 3n. Now we need to divide both sides by 3. If we divide both sides by 3, our n is equals to 28, right? So in conclusion, we can say there are 28 terms in this sequence. So there are 28 terms in this sequence. Now, let's calculate B. So for B, it says the even numbers are removed the even numbers, right? So what are even numbers? We say these are numbers that are divisible by 2, right? So any number here that will be divisible by 2 is an even number. Now they say calculate the sum, right? Keyword, calculate the sum of the terms of the remaining sequence. So if we are to remove all the even numbers, that means we'd be removing 20, removing 26, and then here, if we are to continue with this pattern, we would have 32, because remember, we have a difference of 3, right? So if we say 29 plus 3, this is 32, 32 plus 3, this is 35. But then remember, we are also removing this 32. So you can see the trend here will be just removing a value, then we leave this one, remove a value, leave the uneven number, remove an even value, leave the uneven number. So now, if we can form a trend out of the uneven numbers that will remain, that means we'd end up with 23, 29, 35, then whatever values that we'll have, but also 101, right? So we are including this 101 because, as we can see, it's an uneven number. If you divide by 2, it will obviously leave a remainder. So it's not divisible by 2. Now, let's look at this. Forming this new pattern of uneven numbers, that means we have created a new pattern which will have a new common difference, right? So we'll say 29 minus 23, that's 6. 35 minus 29, that's 6. So that's the common difference that we have. Now, the last term is 101. Now, if you want to calculate the sum, we know the formula to calculate the sum for an arithmetic sequence is Sn is equals to n over 2, and then this is 2a plus n minus 1, and then we have d, right? So what is our n? Our n is equals to, let's look at this. Here, we concluded that we have 28 terms. So the term before they removed anything, we had 28 terms. But if we are to remove all the even numbers, you can now tell that we are removing a value, leaving this one, removing a value. So that means we'd end up with 28 divided by 2, and then this is 14 terms. So that means continuing with this pattern of uneven numbers, we'd only have 14 terms that are uneven. And also as well, we'd have 14 terms that are even, right, to make up this 28. So that means here we'll say 14 over 2, and then this is 2. What is my A? My A this time is not 20, it is what? 23. Remember, I formed a new pattern. Plus, the n is 14. So I have 14 minus 1. Then d is what? 6 this time around. Then let's close here. So when we punch all this in our calculator, this will give us 868, right? So this is the sum of the 14 terms that are uneven. Now, there's also another way in which you can solve that by using the formula Sn is equals to n over 2. Then instead of writing all this, you just say A plus L, right? So this is not written in the back of your formula, but you only use this formula if you know the value of the last term. So it might come in handy just to make things a little bit easier for you. If you know the value of the first term, you know the value of the last term, you can just go ahead and substitute your n. It's 14 over 2. Then what is the value of the first term? According to this pattern, it's 23. Then what's the value of the last term? It's 101. So you just say 23 plus 101. If you punch all this in your calculator, this still gives you sum of 14 terms. It's 868. So either way, you are still correct. So if maybe you feel that this formula is convenient for you, you can take it and know how and just apply it. But then you have to know exactly when to apply this formula, only when you know the value of the last term. So it's when you know the value of last term, right? Only if you know the value of the last term. If you are not given the value of the last term, do not even dream of this formula here. Okay, so, and that's how you would solve that question, guys. All right, so let's look at this activity here. It says, consider the following pattern. you are given 1 plus 2 plus 3 is 6. 4 plus 5 plus 6 is 15. 7 plus 8 plus 9 is 24. And then you can almost tell the trend that is taking place here. So that means in the fifth row, we would have 13 plus 14 plus 15. And then if we add this is going to give us the sum, which is 42, right? So we can see that the values that we get here, they represent the sum of each row. So this is the sum of the first row. This is the sum of the second row, sum of the third row, of the fourth, and the fifth. Now they want us to calculate the sum of the terms in the 2010th row, right? So to calculate the sum of the terms in the 2010th row, this is how we're going to approach it. We're going to use Tn is equal to a plus n minus 1 and then d, right? So to look for the term in 2010, we're just going to go ahead here and say T 2010, because we understand that if we find the value using this pattern here, so we are ignoring this part, we are using the patterns, we are using the pattern from the sum of the rows, right? So from the sum of the row, we can see that there is a particular trend here. If we say 15 minus 6, that's giving us 9, right? 24 minus 15, that's also 9. And then we have 9 here. So we can see that the sum of the rows here are giving us an arithmetic pattern. Now, since we can see that this is forming an arithmetic pattern, we can use the arithmetic formula to find the value that will be at term number 2010. If we find the value at number 2010, that value will represent the sum of the term in row number 2010, right? As this one here, this 6 is representing the sum of the first row. This 15 is representing the sum of the second row. The value that we find in term number 2010 will represent the sum of the 2010th row, right? Then what is our A? It's 6. Then N, we're just going to go ahead and substitute 2010. Then minus 1. What's D? The D is the difference, so we just substitute 9 here. Now, if we calculate here, this is 6 plus 2010 minus 1 and then multiplied by 9. This gives us a value of 18,087. And just like that, you have calculated the sum of the terms in the 2010th row. Okay, now let's look at this exercise here. It says, consider an arithmetic sequence which has a second term equal to 8 and T5 equal to 10. Determine the first term and common difference of this sequence. Right. Now I want you to consider this. T1, we say this is the first term, so it's represented by A, right? This is the first term. Then if we wanted to find T2 using this formula, Tn is equal to A plus n minus 1d. If we wanted to find T2, agree with me that we would say T2 and then we'd say A plus, then where there's n, we'd say 2 minus 1, and then this is d. Now 2 minus 1, this would give us A plus d. Suppose that we wanted to find T3. We would say A plus bracket 3 minus 1 and then d. This would give us A plus 2d, right? Suppose that we wanted to find maybe the 10th term. We would say A plus 10 minus 1 and then d. So this would be A plus 9d. Does this make sense? Are you picking a trend from here? Definitely. We can say that if we are looking for T10, what we have here is 9d. If we are looking for T3, what we have here is 2d. If we are looking for T2, what we have here is 1d, right? If we are looking for T1, it's just A. Now, that means we can use this in order to come up with equations to represent what we are given here. So remember, with solving this, you must take the word problems that you are given here and try to write them mathematically. Right. So now let's use that and express this. We have considered an arithmetic sequence which has a second term equal to 8, a second term. So a second term T2 would be represented by A plus D. But T5, on the other hand, would be represented by T5 is equal to A plus 4D. For both of these terms, we are given the values. For second term, we are given 8. So this would be 8 is equal to A plus D. And then here, this would be 10 is equal to A plus 4D. Now, at this point, you can see that we can try to solve this simultaneously by making A the subject of the formula. So if you make A the subject of the formula, this is 8 minus D. Let's call it equation number 1. Here we'll have A is equal to 10 minus 4D. We'll call this equation number 2. Now that both of these equations are expressed with A being the subject of the formula, we can just say equate equation 1 and equation 2. So we take this 8 minus D and then we equate it to 10 minus 4D. Right. So this would be, if we say negative D plus 4D, and then here we have 10 minus 8. This will give us negative D plus 4D. It's 3D, and then it's equals to 10 minus 8. That's 2. So if we divide both sides by this 3, D is equals to 2 over 3. Right. Now, we have determined the common difference. But how can we determine the first term? We can just simply choose any equation, whether equation 1 or equation 2, and just substitute the value of D. Let's go with equation 1 because it looks much simpler. So this is A is equals to 8 minus 2 over 3. Right. So the value for A would be 8 minus 2 over 3. This would give us 22. So this would give us A is equals to 22 over 3. Right. And that's how you solve this, guys. That's exactly how you were supposed to solve. So now that we have A and then we have D, so A is 22 over 3 and D is 2 over 3. Now they're saying determine the nth term. Right. So for the nth term, just go ahead and say Tn is equals to A plus n minus 1 and then D. The A is 22 over 3, then plus n minus 1. Here we have 2 over 3. Right. So this will give us 22 over 3. Then if you multiply this, this is 2 over 3n minus 2 over 3. So 22 minus 2 over 3, that gives us Tn is equals to 2 over 3n minus 20 over 3. So this becomes our general term or our nth term. Right. Now they say determine the sum of the first 50 terms. Keyword, the sum. Right. The sum. So if they mention the sum, what are we supposed to do? Sn is equals to n over 2, 2a plus n minus 1, and then d. Right. The n is 50 over 2. Then remember A, we got 22 over 3, right? Then plus, again, 50 minus 1. Then D is 2 over 3, right? So all we have to do is punch this in our calculator. So that's 50 over 2, bracket 2 times 22 over 3, plus 50 minus 1 times 2 over 3, then close bracket. This gives us 3,550 over 3, right? So this is the sum of the first 50 terms, right? If you SD that one, gives us about 1183.33, right? But then you can also leave it at that point. Okay, so given the finite arithmetic sequence 5, 1, -3, and then we are given -83, and then the last value here is -87, right? So this is what is an arithmetic sequence. Finite means that it has an end, right? So as we can see here, we are given the last value. So it's just it's not a sequence that just goes without any end, right? So A says write down the fourth term, which is T4 of the sequence. How are we going to write this? Obviously, we will need to know our common difference, right? To find the common difference, we've already discussed that we say T2 minus T1. So this is equals to 1 minus 5. That's equals to -4. If we can just check if it is consistent, we just say T3 minus T2. This is equals to -3 minus 1, also -4. So we can see that our common difference is consistent. That means our arithmetic sequence is consistent. So in order to get the next value here, we just need to subtract 4 because this is 5 minus 4 is 1. 1 minus 4 is -3. So that means -3 minus 4 must give us term number 4, which is -7. So for just that one mark, you just say T4 is equals to -7. B says calculate the number of terms in the sequence. So in order to calculate the number of terms in the sequence, what is it that we need to do? We've already discussed that if they gave us the last term, understand this, guys, if they gave us the last term, it is quite easy to find the number of terms. We just calculate the position of the last term. So finding the position of the last term will help us to conclude how many terms are there, right? So we know that the position of the last term indicates the number of terms in that sequence, right? So this is Tn is equals to A plus n minus 1 and then D. So what is our Tn? We substitute -87. Then what is our A? Our A represents the first term, which in this case is equals to 5. So we have 5 plus, and then this is n minus 1, and then D is -4. Remember, we are looking for this n, the number of terms. So that is represented by n. So -87 minus 5 is equals to -4n, and then plus 4. When we do this, that's -87 minus 5. That should give us, let's punch it quickly in our calculator, -87 minus 5. That's -92, right? So -92. Then we can bring over this 4, minus 4, -4n, right? So this is -96 is equals to -4n divided by -4 divided by -4. Our n is equals to -96 divided by -4. That's equals to 24. So in conclusion, we can say, therefore, there are 24 terms, right? So there are 24 terms. So just like that, we found that -87 is in the 24th position. Therefore, there are 24 terms, right? Then C says, calculate the sum, right? So keyword sum. Calculate the sum of all the negative numbers in the sequence. Now, looking at this sequence, this arithmetic sequence, we can see that the only positive values are 5 and 1. So the rest of the values here are negative. So if we are to calculate the sum of all the negative numbers in the sequence, we need to know how many negative numbers are in the sequence. Now, we had calculated that the number of terms in this particular sequence were 24, so including these 2. Now, if we are only looking for the sum of the negative numbers, we need to say 24 minus 2, then we'll only be left with 22 negative terms, right? So we have 22 negative terms. Now, to calculate the sum, we need the formula Sn is equals to n over 2, and then bracket 2a plus bracket n minus 1, and then D, close that big bracket. So for our n, what are we going to be substituting? 22, because we have 22 negative terms, right? Then this is bracket 2. What is our A? Our A cannot be 5 this time. it needs to be -3 because we are considering only negative numbers. So the first negative number that we have from this sequence is -3. Then plus 22 minus 1. Then what is our D? Our D doesn't change because in a way we did not change the pattern as it is, but then we only just dealt away with 5 and 1. So our common difference is still the same. It's -4, right? So let's close all this. Then punch all that in your calculator. You have 22 over 2, big bracket, 2 times -3 plus 22 minus 1 multiplied by -4, right? Then if you punch all that in your calculator, you get -990, right? So that is the sum of all the negative numbers in the sequence. Nice one. Then let's look at D. For D, they say consider the sequence 5, 1, -3, then they gave you -83, -87, but this time your -87 is not the last term. The last term is -4,187. And then the question here was supposed to be this: determine the number of terms in the sequence that will be exactly divisible by 5. Now, this is what you need to understand. In order for a number to be divisible by 5, these are the conditions. It needs to either end with a 5 or a 0, right? So in order for a number to be divisible by 5, it either needs to end with a 5 or 0. So the examples are, if you have 5, 5 is divisible by 5, it ends with a 5. And then 10 is divisible by 5, it ends with a 0. 15 is divisible by 5, it ends with a 5, right? So we can go on and on, writing all the numbers that are divisible by 5. But then here, we must write the numbers that are divisible by 5 that will be coming from this sequence. So it's not just any number, any number that will be divisible by 5. It's a number that has to be within this sequence, right? So that means we have to further write this sequence so that we have all those numbers. So we have 5. At this point, we only see 5 is divisible by 5. Then this is -3, but then we know this, the term that will come after here is -7. If we say -4, because the common difference is -4, -7 minus 4, that gives us -11. Then if we say -4, again, we have -15. Now, looking at this, we can see now that we have 5, and then we also have -15 being divisible by 5. Now, if this trend is to continue, if this trend is to be consistent and continue like that, we can now create a pattern from all the numbers that will be divisible by 5. How so? So we know that this is 5, this is -15. Let's look at the common difference between these two terms that are divisible by 5. So we need to say -15 minus 5. This gives us -20. Now, if this sequence or pattern is to be consistent, the following term from this sequence that needs to be divisible by 5 needs to be 20 units away from -15. So we want to say -15 minus 20, right? Then we find that the next term that will be divisible by 5 is -35. So also another term that from this sequence that will be divisible by 5 would say -35 minus 20, then it would be -55. So if you were to continue with this pattern, you would then find out that this is true. All those values appear in this sequence, right? But then now, let's look for the last term that will be divisible by 5 from this sequence. Now, how can we find that one? Look at this. We know that the last term is -4,187. But this number here is not divisible by 5 because look at it, it ends with a 7. So if we have to go back, right, with this sequence, going to the right-hand side, we are adding by we are subtracting by 4, right? So it's -4. This is 5 minus 4, and then 1 minus 4 to get the following term. So in order to get the previous term, we would have to reverse it and say, let's add 4 to this, right? So negative 4187 plus 4, then it means we would get the term in here. This is negative 4183, right? So this would be the term that comes before the last term, right? But then still, this number is not divisible by 5. So let's continue. Let's add 4, right? Remember, we are going back, right? Then this is negative 4183 plus 4. We have negative 4179. Still, this is not divisible by 5 because look at the last digit, it is 9, right? So the conditions for a number to be divisible by 5, it either needs to end with a 5 or 0. So again, we're going to add 4 to this number. So be patient with me. Then now look at this. We have negative 4175. There we go. There we go. This number here ends with a 5. So this means this is the last value from this sequence that will be divisible by 5. The last value of the sequence is negative 4187. But the last value of the sequence that will be divisible by 5 is negative 4175. So I hope that makes sense. So now we're going to put it here, negative 4175. We say this is the last value that will be divisible by 5 from this given sequence. Right. Now that we have that, this is what we are going to do. Right. So we're going to go ahead and try to calculate now. So this is going to be Tn. Remember, we want the number of terms in the sequence. So we're just going to go ahead and approach it like this. Tn is equal to a plus n minus 1d. What is the last value from the sequence that is divisible by 5? It's negative 4,175. So now you get to understand why we needed that value, right? So that we can substitute it on Tn. If we can find the position of this term, then we can be able to conclude how many terms from this sequence are actually divisible by 5. So it's negative 4175. Then our A is 5. Remember, A from the new pattern that we've created, the pattern of all the numbers that are divisible by 5. So this is 5 plus n minus 1. Then our D is negative 20. Right. So we can take this and transpose it over to that side. That's negative 4175 minus 5. That's negative 4180 is equals to negative 20n, then plus 20. Now, if we take this positive 20, we transpose it over to this side, we end up with negative 4,200 is equals to negative 20n. Now, at this point, we understand that we have to divide both sides by negative 20. So let's dividing both sides by negative 20. Negative 20. Then we have n is equals to negative 4,200 divided by negative 20. That's 210, right? So we find our n is 210. That means from this sequence that we are seeing here, there are 210 terms, meant to say, there are 210 terms that are divisible by 5, that are exactly divisible by 5, right? So only 210 terms that are exactly divisible by 5. So please pause throughout the video so that you get to understand the approach that I took solving this one. So this is a fairly challenging question, but then once you get to understand what you need to do, then this becomes an easier question to answer. So make sure that you take your time and try to understand the workings of these questions. Right.